Welcome back, everyone. Today we are going to start Unit 3B, Transformations and Symmetry. As we talked about in class today, we are going to talk about three main transformations in this chapter: reflections, rotations, and translations. So I know that we talked about these a little bit today. I'd like you to start with a little quick check or the warm-up. First, try to identify the congruence transformations. Note that there could be more than one answer. And then see if you can do the next ones after that as well. Here's the correct answer for the first one. So note there could be multiple answers. Number 2, we've talked about a little bit. Remember, these three transformations are known as congruence transformations because the image and the pre-image are congruent. And finally, for the third one, make sure that as long as you said that it's a reflection, that's a great start. However, it did say to verify that it's a congruence transformation. So in addition to just stating what type of transformation it is, you should have verified that it was congruent, the shapes ABC and triangle XZY, that they were congruent to each other. One way that we can use to verify congruence in triangles is using side-side-side congruence postulate. So that's what I chose to do. You can see my work and compare to see if you also had a similar answer. Now, the first thing that we're going to focus on the coordinate plane is drawing reflections. A reflection is a different word for a flip. You always go over the line of reflection, and each point on the pre-image and the corresponding point on the image, it's important for you to know that they're equidistant from that line of reflection. So I want you to keep these questions in mind because they will be your reflection questions at the end. So first, where would the image of point A, so we have A, and then when you do the image of A, you put a little kind of like a quote or a comma or an apostrophe next to A to show that it's the image of A. It says, where would the image of point A be if point A is on the line of reflection? So let's say this is our line of reflection, and point A is on the line of reflection. Where would the image of A be? And then another question says if point A is not on the line of reflection, so maybe it's somewhere over here, what is special about the line of reflection in the segment A to the image of A? So what's special about this segment and the line of reflection? We're going to answer those at the end. Keep those in mind as we go through these examples though. Alright, first I'm going to show you how to do some reflections just over any vertical or horizontal line. So first, it's important that when you graph your vertices that you label them. So you can see I've already graphed triangle JKL, and I made sure to use the first number as the X value, the second number as the Y value. Remember, this is the X-axis going horizontally. This is the Y-axis that goes vertically. Once I have them graphed, I also graphed the line that I was reflecting over. Remember, X equals a number is a vertical line, Y equals a number is a horizontal line. The number tells you the intercept of that line. Now let me show you how to actually reflect over a vertical line. So first, you're going to take any point to start with. Let's go ahead and start with point J. So in order to reflect point J over the line, you're going to see how far away is point J from the line. It looks like it's 4 units away. You have to go 4 units away to the opposite side to find the image of point J. You have to go to the opposite side over the line of reflection. Also, make sure you always count exactly vertically or horizontally to find the distance to the line. Remember, distance from a point to a line is something that we've learned in the past if you need to go back and review it. Point K is 2 units away from the line, so we have to go 2 units exactly on the other side. Once you find all 3 images, then you can connect it to find the image of the triangle. Now notice I labeled each point when I found the image, and I used the little apostrophe or dash to show that it's the image. And one way that you can just kind of visually check your answer is to see, does triangle JKL look like it is the same shape and size as the image? To me, it looks pretty good. So I'll say, I think I did it correctly. Now let's try to reflect over this horizontal line, y equals 2. Notice point J is 1 unit away, above the line, so the reflection is going to be 1 unit below the line. Similarly, point L is 1 unit below the line, so the image is going to be 1 unit above the line. Finally, for point K, notice it's 3 units away below the line, so I'll have to go 3 units above the line of reflection to find the image. Again, you can double check by double checking if the shapes look congruent. Now there's some on the next page for you to practice. If you feel like you need some practice, you can try them. Here are the correct answers. Alright, let's do another one where we reflect over the x-axis now. So if we are reflecting over the x-axis, we know that we can highlight it just the same as any horizontal line. So it works the same. Let's start with point A. Point A is 3 units above the line. So I'll go 3 units below the line to find the image of A. So the image of A lands at this point. That is -5, -3. Point C, I'll do the same, go 2 units below the line. And finally for point B, since it's right here, it's 0 units away from the line of reflection, I go 0 units on the opposite side, meaning that it does not move. Alright, so there's my image. Now, I said that point A was at the point -5, -3. The image of B was at 2, 0. And the image of C is at the point 1, -2. So a trick that you can use to check this answer is whenever you're reflecting over the x-axis, you just multiply the y value of each vertex by -1. So notice the y value gets multiplied by -1. Now let's try it over the y-axis. Similar to reflecting over any vertical line, we can see how far away is the point to the left or the right, and go the same distance on the opposite side of the line. Point R, for example, is 2 units away from the right side of the line of reflection. So we have to go 2 units to the left of the line of reflection. Point S is 4 units away from the line of reflection, so we'll go 4 units away on the opposite side of the line of reflection to find the image. Finally, connect all the points to find the image of the reflection. Now a trick for this when you're going over the y-axis is to multiply the x value of each vertex by -1. So for example, you'll see, just for one example, Q, the image is at -2, 3. The x value is multiplied by -1. Now there's a couple practice problems here for you to try if you want, and here are the answers. If you feel good though, you don't have to do these. I know it can get repetitive with graphing all the points. But there's one more type that we need to go over together. This is a reflection over the line y equals x. Y equals x is a straight line. It has a slope of 1, since it's the number coefficient of x is 1, the number in front of x is 1. Remember, we can use the form y equals mx plus b. And for the b value, it would be a 0, meaning that the y-intercept is at 0. So it goes through the origin, and it goes up 1 over 1, up 1 over 1, and so on, because the slope is 1. So I went ahead and graphed the reflection here. Now let me explain how to do this. Anytime you're trying to reflect over the line y equals x, all you have to do is switch x and y. So for example, for the point J, X and Y are actually the same. You can see already on the line of reflection. When you switch X and Y, it's still 2, 2. Since it's on the line of reflection, it stays where it is. Point K, though, is a little different. Point K, when we switch X and Y, we'll get 1, 4. So I know the image of K is going to be over 1 up 4. That's how I knew where to plot the point for the image of K. Similarly for L, when I switch X and Y, I get -3, 3. And for M, I get -4, 0. It might be helpful for you to write out these points first and then graph it. The thing that's helpful about reflecting over the line y equals x is that it can help you with inverse functions once you get further along in math. So you'll definitely want to know at least an idea of what this looks like, reflecting over y equals x. If you feel like you need some more practice with this, go ahead and try the practice problem below. Here's the correct answer for that practice problem. And that's where we're going to stop for today. Remember, please answer your reflection question. I'll give you a chance to answer that in a pop-up. And tomorrow we're going to start talking about translations in the coordinate plane. You should have an idea of what they look like. Tomorrow we'll learn how to do them. Talk to you then.